Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. So we continue our lecture 3, linear equation. Okay, previously we learned about matrices, we learned about how to find a determinant and how to find the inverse of matrices. Why we learn that? Because of we want to solve the linear equation system. Okay, linear equation system consists of many linear equation. Okay, so for this lecture content, we will cover on first topic, which is introduction to linear equation and linear system. And second is type of solution of linear system. And third is solution of linear system by using Gaussian elimination, inverse of a metric, Cramer rule. And fourth is special case, variable, constraint, greater than constraint, and homogeneous linear system. Okay, now for this first topic, what is linear system and linear equation? Okay, linear equation previously we already know it is, if we illustrate it in a graph, is linear graph, garis lurus. Okay. Okay, a linear equation is an equation that does not involve with any product of root of variable. Because of it is linear, it only have one root, or we call it as satu je persilangan, or all variable occur only the first power and do not appear as argument of trigonometric, logarithmic, and exponential function. Because if we graph the trigonometric, logarithmic, and exponential function is not linear. It have a curve. Okay, in other words, a linear equation is an equation of a straight line. Okay, like the previous statement is only first power. Okay, first power meaning that all variable involve power of 1. Like this, if you can see x power of 1, even though it's time 1 over 2, but it's still x power of 1, y power of 1. Same goes to other example in here. Okay, then for the linear system is mathematical model of system based on the use of a finite set of linear equation, meaning that it have many linear equation which is finite, which is dia bukan tidak terhingga, dia terhingga, which is we know the linear equation value, which mean sama ada dia 5 linear equation atau 6 linear equation yang terlibat atau 7 linear equation yang terlibat. Maksudnya kita boleh determine berapa yang terlibat. It is not infinite. It's a finite set of linear equation. Okay, it is formally known as a system of linear equation. Okay. In other words, a linear system is a system that consists of minimum of 2 equations working together. If we call it as a linear system, meaning that it at least have 2 linear equations. Okay, the variable in the linear system are called unknown. Okay, like we see previously, x, y, x, y, x, and z here, it is unknown. Okay, we don't know the value, the exact value of it. We wakilkan dia sebagai, we represent it as a one alphabetical number. Okay, letter. Okay, now a general linear system of m equation in the n unknown x1 until xn, kita boleh written as, we can be written as A11x1 until xn is equal to b1. Same goes to second row, A21x1 plus A22x2 until A to n xn equal to b2. Okay, this is the general form. Okay, a solution of linear system is n unknown, which is the x unknown involved. x1, x2 until xn is a sequence of n number, and s1, s2, sn for which the substitution, okay, makes its equation
a true statement. Okay, now, for example, if we have like this, okay, the unknown is x and y, and the value of scalar times x is 5 and y 1y. Okay, hence the solution x is equal to 1, y is equal to 2. Previously in your secondary school, you learn how to solve this by using elimination method, right? You name it as a first equation, and this is as a second equation. Then for this equation 1 plus equation 2, and we can solve it. We get 5 plus 2 is 7x. Y plus negative y, it is 0, is equal to 7. Then x is equal to 1. Okay, we get x is equal to 1. Then from this number 3, we put it in number 1. For example, it is 5 times 1 plus y is equal to 3. And this is y is equal to 3 minus 5. And it is equal to negative 2. Okay, that's why we get y is equal to negative 2. This is the method, we call it as elimination method. You are using it in secondary school. Okay, now let's move to the next slide. Type of solution of linear system. Okay, this is all possible solution of linear system. It may have no solution because it's not intersect anyway for the first possibility, and second possibility exactly one solution, and third possibility it is infinitely many solution. Okay, if we want to figure out the possibility, this three possibility, we may figure out like this. Okay, for first one, which we call it as inconsistent because it has no solution. It's parallel. The two lines that involve in this system linear is parallel. That's why it has no solution. But if these two lines intersect at one point, it may have one solution. Okay, the third possibility just now, where it is intersection, which is the line number 1 and line number 2 in the same place throughout the process, which is it has infinite solution. Okay, in general, we say that linear system is consistent if it has at least one solution, and inconsistent if it has no solution. What does it mean? Independent mean that each equation gives new information, otherwise they are dependent. Okay, independent and dependent. Okay, this is the meaning of independent and dependent. Okay, for the number 3 topic, which is we want to solve a linear system. Today we will have to discuss Gaussian elimination method, Gaussian elimination to solve linear system. Other than that is inverse of a matrix, another one process to solve linear system. And the last one is Cramer rule. Okay. This is the 3 technique in order to solve a linear system. Okay, now there are variety. Okay, technique. Just now I already mentioned there is 3 technique that we will focus to solve a linear system. Okay, for the first technique, Gaussian elimination, or we call it as Gauss-Jordan elimination. It involves elementary row operation. I already do a example elementary row operation in lecture 1. You may see my recorded, and in lecture 2 determinant is also involve elementary row operation. You may see in the recorded. And this is the third chapter. We will learn again what is elementary row operation. It involves switching the row. We switch row 1, for example, with row 2, then the row will change. Then row multiplication, we times the row with one number, or another one is row addition. We add row with one number to get the value that we want. For For this row addition, we usually want to get 0 for the entries, the 0 number kita nak. We want to get, for example, it is 1, 3, 2, 0, 1, 2, and this is 3, 2, 1. Remember previously, we want to get this place 0. Okay, that's why we have to do row addition. So we have to put -3 plus 3 so that we get this place 0. So -3 we have to times with the diagonal 1. Penjuru yang satu dekat situ dekat atas. We refer to the above value. It is in R1. So when it is 3 is in a row 3, so the row addition formula for this is 3R1 plus R3. Okay, this I recap again. Okay, this is what we call as a row addition, to make any place to be the number that you want. For this case, we want the 3 in the row 3 to be 0. So this is the formula for the row addition. Okay, now let's move to the next slide. How to solve it? Okay, this is where we found that our matrix has one solution if it can get this pattern. And if it is like this, the system has infinitely many solutions. If there is pattern like this, at last line or the last any row, get all entries 0. This is what we call it as infinitely many solution. And the number 3 in any point in this process, if we get like this, which means yang ni ada value, but this all value is 0. Okay, if any point in this process we obtain a row with all zeros like this, but the right one, there is number, this show that the system has no solution. Okay, if you found like this pattern, we can conclude that there is no solution. For this pattern, we can conclude that there is infinitely many solutions. Or we get this, we can conclude that there is one solution for this system. Okay, now we move. Example 1. Okay, now we have to convert from this linear equation to this metric system. Okay, so this linear equation become, okay, 1 times x, so it become 1. 1 times y is become 1. 2z, so here is 2z. So this is 2x, 4y, 3, negative 3z. That's why we put 2, 4 and negative 3. So for the third row, 3, 6 and negative 5. So here we put it as 3, 6, negative 5. Okay, now we have x, y, z, and here is the third, this is our solution 910 for the value of b. Okay, this is our matrix A. If we are referring to this, and this represent our x, and this represent our B matrix. Okay, this is A matrix, X matrix, and B matrix. Okay, this by using this sentence. Okay, now we move by using the Gaussian elimination just now, right? Okay, now how to solve it? Okay, now we have the matrix A just now and the matrix B. We put it side by side together like this. Then you may do elementary row operation to get like this: 1 0 0 0 1 0 0 0 1, and this value later will be your solution. Okay, we want to do operation to make this matrix become this. Okay, so let's start the operation. Okay, now, elementary row operation. Now, here we found that our matrix in first element here is already 1. So, no need to change anything. Now, focus to the second and third row here, 2 and 3. Okay, it's depend on you whether you want to make this first as 0 or this first as 0. Okay. If you want to make this, okay, we'll just follow the tutorial here. Okay, now this person want to make this element 0. Okay, this is 2, right? So we have to know that we have to tolak 2 kan? 2 tolak 2 become 0. So we want to make this element 0. So now we refer to the first perpenjuru element here is from the row 1. And plus and 2 here is in a row 2. And we want to change row 2. That's why this formula we get like this. Okay, now, remember, please do all operation involved in a all row 2 element. Row 2 element we have to change. But for row 1 and row 3, just copy it again. Copy it again. So we do it. Okay, negative 2 R1, negative 2 plus 2 becomes 0. And here, negative 2 R1 is 1 plus R4 is 4, which is negative 2 plus 4, it becomes 2. And for the third element here, negative 2 times 2 is negative 4 plus R2 is negative 3. Here it is negative 7. Okay, now here for the last element 1 here, we have to change it. So, negative 2 kali R1, R1 ialah 9. So, negative 18 campur 1. So, dia ialah negative 17. So, all this row 2 element completed. So now focus on the third element. We want to change it to the 0. Okay, the formula here, if we want to change it, it become negative 3 plus, okay, 3 is in a row 3, right? So row 3, so negative 3 refer to the perpenjuru element 1 here in a row 1. Okay, then change row 3. For row 1 and row 2, please copy it again. So this is the next formula. Okay, let's see what this person do. Okay, like I mentioned just now, where it's come from. Then we do the elementary row operation for the whole row 3. Okay, now we found that negative 3 R1 is 1, minus 3 is 0, and negative 3 R1 is 1. So negative 3 plus 6 is 3. And we have negative 3 R1, negative 6 plus negative 5, it's become negative 11. So for the last element, it is negative 3 times R1 is negative 27 plus R3 0. So it is negative 27. So complete for the first column. So now our focus is to become this one. How we want to make it as 1? Okay, to make it as 1, we have to divide R2 with 2 and we get R2, the new R2. So now it become what? Kita tengok orang ni buat ya. Okay. Nampak tak? R2 bahagi 2. So all the R2 will be bahagi 2. We get the new R2 here. Okay, from negative 77 become negative 7 over 2. Negative 17 become negative 17 over 2. So for the line 1, row 1, row 3, just copy it. So now we already get this like this. Okay, now depends whether you want to make this as 1 or you want to make this and this as 0 first. It's depend on you. But for this contoh, they change here to become 0. Okay, dia nak jadikan yang ni kosong. So, this is the formula. I hope that is in this stage you already know how to convert this, how to make this formula, which is this is 3. That's why minus 3. And the perpenjuru one is in row 2. So that's why it is row 2. And plus 3 in a row 3. So R3 in a row 3. Change R3. Okay, so we have to change all these element to become a new number but remain these 2 row. Okay, then you may calculate it by yourself. Then we may get this, the new number for the R3. So now focus on the R1. So here this person want to make this as 0. So we have to follow the diagonal number R2. That's why this is R2. Tolak 1 because this is 1. 1 minus 1 becomes 0. And for the rest element have to follow this rumus buat ya. Okay, no need to worry about pecahan. If you are do more exercise with pecahan, you will good in pecahan later. Okay, then after we get this, okay, depends. Okay, now the tip is make this as a 1. How to make this as a 1? We have to times R3 with 2 negative 2. So here when we times it with negative 2, it's become 1. Okay. So that's why this is R3 times negative 2. So yang bawah ni become 1. And yang sebelah ni pun kita change with this formula also. Negative 3 over 2 times negative 2, it become 3. Okay, so now the way this person do, he change this element. So depends whether you want to change the element of this element. So let's focus like this. So we make the first row, change it. Okay, now, 11 over 2. How we want to make 11 over 2 become 0? So, it must minus with itself. So, tolak 11 over 2 times. Now, the perpenjuru, the diagonal number 1 is in a row 3 and the element that we want to make it 0 is in a row 1. So, we use R3 plus R1 and change R1. So the rest we copy it again, then make all the R1 become the new R1 by using this formula. Okay. Then here for second row here, we want to make a change to this element. So it must minus to itself. So become 0. So because it is negative, so we have to minus with some with positive number. Then 7 over 2, R3 plus R2 and change R2. So we get this. Okay, until we get identity like this, so we know already this is the X value, Y value and Z value. And we get the solution. Okay, stop. We get the system of linear solution. Okay, now this is by using inverse of a matrix. Just now yang in the lecture 2, you already learn about inverse matrix by using cofactor expansion. Okay, now we can find a solution for this. Okay, convert this to this. Okay, you already know how to convert it, right? So just put the element of this number to this matrix and look at the unknown is x1, x1, x2, x3, put it here. And this is the value of B, 5, 3, 17. Okay, here. Now we want to do a cofactor punya technique. Okay. So for this technique, we using cofactor expansion. Okay, remember again? Cofactor, how to find a cofactor by using the matrix, inverse matrix. Macam mana? Okay, tadi kita ada, sekejap saya tulis dia punya matrix. Yang ni kan? Okay. 1, 2, 3, 2, 5, 3 and we have 0, 1, 8. Okay, this is the matrix. Okay, 108, 108. Okay, now, okay, this is our matrix. Just now, A, yang matrix A kita 1, 2, 3 from the question. 2, 5, 3, and 1, 0, 8. Okay, now, for this, okay, we want to do a cofactor. Remember again, what is cofactor matrix for this A? Okay, okay, it is what? Okay, so now it is, okay, calculate. Here, it is -1 kuasa 2. Okay, untuk tempat yang pertama. Okay, it is -1 kuasa 2, so it is 1. So, kita ambil yang ni. 5 kali 8, 40. 40 tolak, kosong, it is 8. Okay, saya salah. Okay. 5 kali 8, 40. So, yang pertama ialah 40. Okay, unsur yang kedua ialah yang dekat sini. Ini ialah cofactor. Yang previously kita kira -1 kuasa I plus J M I J. Yang ni, how to calculate a cofactor yang lecture 2 tu. Okay, so now the second element is, okay, this is -1 sebab -1 kuasa 3. Okay, -1 kali dengan, okay, kita tutup yang ni, MIJ dia ialah 2 kali 8, 16. 16 tolak 3, 1, 2, 3. So, it is 13. So, it is -13. Macam tu. Okay, so kita dapat ini ialah -13. And lepas tu kita kira apa lagi? So dekat 3 ni, 3 ialah ini ialah place row number 1, element number 3. -1 kuasa 4. So it is positive number. So MIJ dia dekat situ 2 kali kosong tolak 5. So kosong tolak 5, -5. And the second number here, the second element, remember again, cofactor. Okay, so cofactor ni yang keempat ni ialah -1 because of kuasa 3. Okay, tutup this first column and the second row, so it become 16 tolak kosong, -16. Okay, so 16 tolak kosong. So, dia ialah -16. Betul. Okay, so sekarang this is the cofactor. Okay, ni nanti kamu teruskan. Dapat cofactor, teruskan dapat nilai ni, dan seterusnya lepas dapat cofactor tu, you may calculate again to get adjoint. What is adjoint? Adjoint A. Okay. Transpose this cofactor. So, 40, 13, 5. Okay. Then dapat, ini ialah -16. This value. After you calculate adjoint, you may get the inverse by using what? This adjoint, yang ni semua ni, adjoint ni, kena letak dekat sini, value dia semua, kena bahagi dengan, will bahagi dengan determinant of A. So, this is the inverse value. So, the inverse value yang ni is coming from the method that I show you just now. Okay. So, sekarang, how to calculate the X, Y, Z. Okay, so now, X is equal to this inverse matrix times with 5, 3, 17. So, 5, 3, 17 is coming from the question. Okay, if we get the inverse right here, then we times with B matrix, then we get the solution. So this is the solution for 1, -1, and 2. Okay, now the solution of linear system is S1 is 1, S2 is -1, and S3 is 2. Okay, now for the Cramer rule here, Cramer rule throughout the process, we find the determinant. For example, here we have question like this, we transfer to the matrix to become like this. So what is Cramer rule? Cramer rule is, first you have to find a determinant of your matrix. So you get the determinant, it is 2. So The next process is replace 4 to 5 here in the first column. Become A1 in the first column. So, replace the second A2 with 4 to 5 in the second column. But the remaining, jangan ubah daripada matrik asal. 530, 221 is coming from the matrix asal, original matrix. And for the A3, replace B with 4 to 5 in the third element here. So in this A1, A2, A3, please find a determinant. Okay, we get the new determinant for A1, A2, and A3. Then you may divide each A1, A2, and A3 with the original determinant 2 just now to get the value for the linear system. So we already solved the linear system with x1 is 1, x2 is negative 11, x3 is 16. I don't show you how to find this determinant, each determinant, because I already assume that you already master how to solve a determinant. And this is the special case where the variable is more bigger than a constraint. Okay, yang ni kalau ingat balik, my first that I mentioned to you, the second possibilities here, which is it's infinitely many solution, which is it has one row with all 0 element, macam tu. Okay, so now this topic, the coming topic is to discuss of that type of a matrix. Okay, this the fourth topic. Okay, now this linear system, okay, then convert it into a matrix, we get this. Okay, semalam ada yang tanya, there is a question, why don't we put this as 1, this as 1, and this as 1? We can't make it as 1, 1, 1 because throughout the process we do a row operation, yang ni dia automatically dia jadi 0 tau. It's become 0. It's not from our kita kebetulan dia dapat 0, so we can't make any row switching because kat bawah ni dah tak ada value. Okay, that's why we remain it as it is. Okay, so we get ni 1, 2, and when do a row operation, kebetulan kita dapat yang dekat sini 1. So we already know that this is the place for x6. So we know that x6 is equal to 1 over 3. And the second row, it is x3 and x4 here. So x3, x4 is equal to 0. And for the first row, we get this equation. Then from this equation, we make x1, x3 and x6 as a perkara rumus. Okay, x1, x3 and x6 as a perkara rumus. Then what is the value for x2, x4 and x5? Okay, so we may put it as a 1 alphabetical, which is unknown. So x2 ialah R, we may put it as R, and x4 is an S, and x5 is T. So because of x3 is equal to x4, that's why this is negative 2S. And our x4 is S just now, and x5 is T, and x6 we remain it as 1 over 3. So there is no unknown involved in x6. So it is real number. So x6. So this thing, if you can't get what I said, please rewind this statement, this video. Okay, now homogeneous linear equation. This is where we call it as a homogeneous, which is it has trivial solution and non-trivial solution like this. Okay, A1 and B1 nodes both 0, and we have like this. Okay, this is when we have infinitely many solution. In early of this lecture, I already mentioned to you, bila dia bertindan dua-dua garis tu, meaning that it has many solution. Okay, if something like this, it show us there is one trivial solution, only the trivial solution for this. Okay, then this is the another example for homogeneous linear system, which we have like this, and we convert it into the metric, and we do row operation. We get like this. Then if we have this kind, we have number, but this place we don't have number, it means that, okay, x6 is equal to 0, and this is x3 plus 2, x4 is equal to 0, and for the first row, we replace it again with the unknown, okay, then this kind of solution, we make x1, x3, and x6 as a perkara rumus, then we may replace x2, x4, x5 to the one unknown letter. Okay, so that's why we replace x2 as R, x4 as S, and x5 as T. Then replace it to the place where x2 become R, x4 S. That's why x3 is become negative 2, x4 it become negative 2 S. Okay, then we may see that the trivial solution result where is R S T, whereas we know that it is equal to 0. Okay. Then this is what we have covered. Okay. So next we will cover on application of linear system. Okay, thank you. If you have many questions, you may ask your friend or you may see me to resolve the problem. Okay, thank you. Wassalamualaikum.